Ever notice how your feet start steering toward your favorite cafe before you've even thought the word latte? Here's the wild part. Your brain locked on to that destination a split second earlier, before any conscious urge bubbled up. It did that by juggling two tiny questions. Where have I been? And how did that feel? Today we're going to crack open the hidden circuit that stitches those answers together and quietly tugs you in one direction over another. First, let's set the stage. Picture a crossroads deep inside your skull called the nucleus accumbens. Think of it as the grand central station of reward. Two incoming trains arrive here. One carries detailed maps of space, street corners, bench locations, the exact cafe door. The other hauls in the emotional Yelp reviews. Was that stop great? Meh. Or terrible. When those trains meet on the same platform, actually in the very same neuron, your next move is decided. Zoom in further and we hit the hippocampus, the brain's mapping department. Textbooks split it into two branches. The dorsal, upper branch tracks layouts, boundaries, the nuts and bolts of where. The ventral, lower branch cares more about mood, stress, and value, the why. For years, scientists treated those branches like separate gossip channels. The new research we're talking about today shows they converge on exactly the same medium spiny neurons in the accumbens. One cell, two stories, place and payoff. Here's the kicker. The where story talks 3 times louder than the why story. That 3-to-1 bias means the circuit privileges crisp spatial details, but still keeps the emotional tag in the mix. It's the difference between drifting toward any nice cafe and beelining for that sun-splashed corner table that's basically got your name on it. Let's make it concrete. Imagine a park dotted with identical benches. For some reason, you keep gravitating to one in particular. According to this study, each visit slightly strengthens the spatial input for that bench while also attaching the memory of how pleasant it felt. Over days or weeks, the small bias snowballs until your legs march there almost on autopilot. It isn't just nostalgia, it's wiring. Timing matters too. Those accumbens neurons light up tens of milliseconds before you actually stand up or take a step. That flash is the integrated go now to there signal that heads off to the motor system. By the time you realize you're moving, the decision has already cleared customs. Now, what happens if you unplug that convergence? If you keep the where and the why on separate circuits? Researchers tried it. Animals still realized something out there was rewarding, but they couldn't pin it to the right spot. Their preference for the good bench, or good food corner, collapsed. Value without context just floats. We even see hints of the same wiring in people. High-resolution brain scans show the back part of the hippocampus flaring together with the accumbens when volunteers vividly imagine revisiting a favorite real-world place. Your mind is rehearsing the map plus meaning code before your body budges an inch. Why does this matter beyond brain geek trivia? Because many psychiatric treatments, deep brain stimulation, exposure therapy, even clever urban design, sit right along this hippocampus to accumbens highway. Depression, addiction, OCD, they're often framed as too little reward or too much threat. But what if the deeper problem is a glitchy link between where things happen and why they matter? Fix the link, and motivation may start to self-correct. Think back to when you first learned a new city. At first, it was a blur. Street after street, nothing sticks. Then, almost magically, one route home just feels right. Maybe it's the bakery that sometimes slips you a sample, or the shortcut that passes a mural you love. Those tiny rewards get stapled to the spatial pattern, and your future choices flow along that hidden spreadsheet. Same thing when habits tip into compulsions. The corner shop, the late-night snack, the phone you check in the same exact chair. The spatial code stays sharp even if the value tag has faded. That mismatch explains why simply knowing better rarely breaks a routine. So, therapies that walk people through triggering places, in VR, in real life, or using gentle brain stimulation, might work by rewriting this joint code. They're not just lowering anxiety or boosting dopamine, they're retagging a map. Let that sink in for a second. Before we wrap, I've got a quick experiment for you. Think of a habit you'd like to tweak, maybe endless scrolling, mindless snacking, or grinding through emails late at night. Step 1. Notice the where. Is it the couch, the kitchen island, the 11 p.m. glow of your laptop? Step 2. Change one piece of that stage. Move to a different room, shift your phone to a shelf, or take a new route home. Then watch how the urge changes. You're basically talking to your hippocampus in its native language. So here's what we covered today, rapid-fire style. 1. Two hippocampal streams, dorsal where and ventral why, meet on the same accumbens neurons. 2. The spatial input shouts 3 times louder, giving specific places a leg up. 3. That fuse signal fires before you move, turning decisions into feelings of automatic pull. 4. Break the convergence and value loses its address. Behavior falls apart. 5. Tweaking that map plus meaning link could reshape habits, therapies, even city layouts. Bottom line, your brain is constantly annotating a personal atlas, pages of streets, benches, cafes, each spot underlined or crossed out based on how it felt last time. Change the map, and you change the motivation. This week, experiment with your own atlas. Nudge one location and see if a different why comes along for the ride. Then drop me a note about what shifted. Until next time, follow the map you want your brain to draw. Because every step rewrites the legend.